me take up the first question for you. So, Professor Oliveira, one of our attendees would like to know what is the difference between hallucinations and creativity in the context of writing research papers using AI. Can AI differentiate between the two of them?
Yeah, okay. So hallucinations occur when the AI create things that do not exist. So give, say, wrong information, for instance. These hallucinations. The creativity, and hopefully not with hallucinations, will come when the machines can get a lot of their information and make connections with their information. I would say that it's a process very similar to what humans do. So when we have a new idea, these new ideas must come from the corpus we have in our mind, so the language that we know. For instance, I can have ideas in Portuguese or in English, which are the two languages that I master. I cannot have an idea in Hindi or in Chinese or in French or in Italian because I do not have knowledge of those languages. And I can also have an idea based on the mathematical formulas that I have in my mind, so my knowledge of maths. And the same applies to the machines. The difference is that the machines have a corpus which is at least 1,000 or 10,000 larger than the corpus than a human can ever have in terms of knowledge of the language, or in terms of number of words in the corpus that we have in our mind. And obviously, the machines can also have a much higher speed of processing text. Just to give an idea, machines can process text with a speed with 10 to the 9 to 10 to the 13th higher than we can. 10 to the 13 means that the machines would process in 1 second what would take us 1 million years to process. So that's the sheer difference between the abilities of the machines compared to ours. And that's why I say that machines will be much more creative than we can possibly can, because it will process much more information than we can.
All right. Thank you so much for the response. Moving ahead, there is an interesting question from one of our attendees. In many instances, if 10 different labs perform the same experiment, it's very likely that they will get 10 different answers. Who decides which data are used to train these AI models? Uh, Moreover, how much confidence can we place in AI-generated outputs if the models were initially trained on poorly selected or inconsistent experimental data?
Yeah, no, that's an excellent question. I mean, in fact, today you have no assurance that we can trust what the machines are doing, because as it has been mentioned, in many cases it may be trained with wrong with data which is not high quality. And in fact, now even if you get AI, if you have a problem of reproducibility, as we know in many cases there are problems of reproducibility. Today we have to rely on human experts to try and resolve this, doing more experiments or compare data, doing meta-analysis and so on. So this is an unsolved problem, and it's going to get worse as we have more and more data available. However, we have an advantage now with AI, because as it can process much more data than we can, they will be better equipped to check whether there is there is a problem with those data, whether there is a problem with reproducibility. So even though we, on one hand, we may have more and more data that may not be reliable, on the other hand, we're going to have tools that can check that. Because, for instance, we humans, like, for instance, if you're analyzing a paper that comes to the journal, and then somebody asks, are you sure that this similar work has never been done? And the question you answer is, wow, unless I use some tools which can give you an idea, it's impossible for any human to say that no other work similar to that has been done, because you cannot check the thousands of papers that are published every day or every month. The machines can. So we will have a tool which will be much better than we have. And in fact, today we say, and it's right to say that, that when you get machine-generated contents, you should always check. We need human supervision because the machines can make a mistake. That's correct today, but this is something which is sort of ironic because we know that humans are not good at that. We're not good at that because you do not have the capability to check everything that's available. So today, because of our limitations, we tend to rely on expert opinions, but our expert opinion is really very limited because even the best experts cannot guarantee that they know everything that's in the literature. And therefore, in the future, say in 10 years, people will think that oh, you are crazy to think that humans can supervise this or that humans can check, because humans cannot check. Humans cannot check the literature that exists today, let alone the literature that will be available in 10 years' time. We cannot do it because we are not capable of processing everything that is available. So in the future, as we develop methods and machines that will be better and better, it may be possible to check whether things are incorrect or not. But it is not going to be a linear process. And before the machines can be guaranteed that they can do everything right, we are going to have this process that we will have to be checking and checking and rechecking the information that comes from these tools or any other AI tool.
All right. Thank you so much, Professor Oliveira, for that response. A follow-up question to that is, given all these challenges that you mentioned just recently, do you believe that standardized high throughput standard manufacturing and characterization will become important for generating the high quality, reliable data sets needed to train the widely accepted AI models?
Yes, yes, that's absolutely essential. So that's something we will need standardization for, and this will probably happen in different areas, and especially to sort of to serve as input for the foundational models. Let me just make an observation. In my talk, you see, I did not focus on the limitations of the AI tools today. There are many limitations. I know that. That's for sure. That's why we haven't got to the fifth paradigm yet, for sure. But I did not focus on that because these limitations are being wiped out, you know, month after month, week after week. So for this audience, I think what matters is what the AI tools will be able to do in 2 years, 3 years, not just next week. That's why I did not dwell on limitations.
Okay. Professor Oliveira, one of our attendees would like to know your thoughts about the inclusion of AI in simple computational studies of molecules. Like, will it enhance the accuracy of simple quantum mechanical models so that values from these computational studies would be much closer to the experimental results?
Yeah, I think that this is already happening. That you can combine ab initio methods to study properties of molecules, especially bigger molecules, with AI. So this is already happening. It's probably going to be extended in the next few years. The main challenges, I think, are especially in complex systems, in which it doesn't suffice to understand every single part of the system, but the properties that emerge from the complexity of the many components in a system. So this is going to be complicated. I give a simple example: the functioning of our brain. That's likely that it's going to take a long time for us to learn a lot about the brain functioning because it's too complicated. And so even the AI tools of today or of the next few years will not suffice for us to understand exactly how the brain works. So this is a very complicated problem which can be tackled better to be better tackled in the future with AI tools. So I'm really hopeful that we're going to make progress, but that's not easy. It's not an easy problem.
All right.
More complicated than understanding molecular properties.
All right. Moving to the next question, a very basic question coming from one of our attendees, that they find it difficult to distinguish between AI and machine learning model. Since machine learning is generally considered a subset of AI, what exactly is meant by an AI model, and how does it differ from a traditional machine learning model?
Okay. So that's again a very good question. I mean, historically, artificial intelligence is the whole field. The artificial intelligence is a field which has as subfields machine learning, computer vision, natural language processing, robotics, knowledge management, and so on. But today, every single application in artificial intelligence includes machine learning. That's why people sort of mistake one for the other. So machine learning is always present in almost any AI application today. So in a sense, we can more or less use the two terms almost interchangeably, exchange the two ones. But we have to keep in mind, AI is broader than machine learning. But now every AI application it also uses machine learning. So machine learning is always present when we are talking about an AI model. But the reason why people use AI agents, not only machine learning, is because in many cases we are also using other areas, other subfields of AI. For instance, when you're doing computer vision, or if you're analyzing data with image analysis, we are using machine learning, but we're also using computer vision. So we are using two subfields of AI. That's why it's perhaps more appropriate to call it an AI tool than just machine learning tool.
Fine. Moving to another interesting question coming in our way. Professor Oliveira, can you recommend any specialized AI tools for writing scientific research or review articles? And in your opinion, which AI tool is currently the most effective one for academic writing and literature-based research?
Yeah. I mean, this is a very difficult question to answer because the tools change every day, one thing. Second, there are free tools, so they're freely available, and there are the paid tools, the tools that you have to pay a subscription, which are usually much better. So I would say that today for scientific research, from the experience we have in our group, the Cloud Code is one of the best to produce an AI scientist, which has because they have a pipeline to do a research project. So that it is one of the most advanced. Um, on the other hand, ChatGPT is excellent to summarize literature, to find new information. But then to write papers, Gemini has been very useful. So in fact, the trend today is to use a suite of tools, not only one. So you may have a system which try different types of large language models and see which is the best one. And in fact, this is also being used to avoid hallucinations. Because if you get text generated by one tool, and then you use another tool, another large language models to check whether that information is correct, and therefore you avoid the hallucinations. But anyhow, to produce review papers, the best thing to do is to use those personalized systems that have been developed. Like in our group, we developed one, as I showed. Unfortunately, our model is not open. It's not everything is open access. We can provide all the details, but we do not have an interface for users to use, unfortunately, because this would require another step in terms of development. We do not have an interface that users can come in and write, suggest a subject and have the review paper, unfortunately, because our system is relatively complicated. But this is very soon we'll have other systems available that can help you on that.
Thank you, Professor Oliveira. That's quite useful. Moving to the next question, large language models are based on tokenization and they pretty much excel at processing natural language. When it comes to mathematics, uh, Professor Oliveira, can you share your thoughts? Is there a possibility that they can move beyond token-based representations to understand mathematical formalism and reasoning?
Yeah, well, I mean, I really thank you for all the questions. They were really excellent. You mentioned reasoning now. When I was mentioning at the beginning of my talk, I predict that computers would master language at some point. My prediction was in 2012, I made a prediction that it would take around 15 to 20 years. So I was not as optimistic as I could have been. But then one thing, when ChatGPT came and the other models as well, one surprise that I had was that there was no mechanism for reasoning. These models learn just by examples. So you provide corpus in context. So you provide text in context and they learn without a reasoning mechanism, which has, I would say, philosophical implications, because probably that's more or less how we humans learn. And I had this idea by comparing with the way I learned my second language, which is English. I learned English as after an adult, so I have some memories of how I learned it. And when I started thinking in English was the day or the time in which I had sufficient corpus in my mind, because I learned with a corpus-based method. So I sort of intuitively created a method to learn scientific English. And then I learned to think in English when I had a sufficient corpus in my mind. And probably that's what happens with the machines as well. Once they have sufficient corpus, they start to reason. And the same way as they did for language, they also do for formulas, for mathematical formulas. So apparently there is no, our intelligence, what we call human intelligence, is not really that much. It's just a combination of what we have in our corpus, in our minds. Um, and that's why my prediction is that the machines will be much, much, much superior to what we have in terms of intellectual tasks. In a few years, the machines will be able to do things that we can never imagine doing ourselves, because the machines will be much better than we are. And I think that's an important point, because if this is true, if this happens, which I believe it will, uh, we are going to have entirely different world when you have machines that are much better than we are. So the world is going to be a different one, and we have to be prepared for that, especially the young people in the audience.
All right. Like you mentioned, Professor Oliveira, towards the end of your talk, that there'll be a lot of questions coming in, and that's what is exactly happening. But probably in the interest of time, I will take just one final question for you. Um, as AI systems became capable of generating hypotheses, designing experiments, and even writing manuscripts, so what do you think will remain the uniquely human contribution in scientific research over the next decade or so?
Yeah, I think that I don't really see any unique feature of us humans in terms of competence for science. I think that the machines will be better than us in everything. Having said that, we hope that the machines will be developed in a way that they can work with us, and they work, for the betterment of human beings, for betterment of society. So I think the main role of the scientists, the human scientists, will be in establishing the agenda, what has to be researched. And it's not too difficult to establish this agenda. This agenda should include the global challenges. Because you see, it's not just developing new technologies that we're going to develop to improve our lives, to improve the quality of life, to increase our longevity, but it's also we need to address the global challenge like inequality, poverty, hunger, wars, uh, the climate changes. All of those big challenges, they are not only depend on technology, they depend on many other things, including human behavior. And that's where I think I see a lot of new developments over the next few years, because the problems related to human sciences and social sciences are much more difficult to deal with than the problems related to engineering or hard sciences. And this we'll be able to tackle with these new ways to generate knowledge. Because I remind you that every time you have a problem, it doesn't matter which type of problem it is. To solve this problem, you need knowledge. You need to create knowledge. And if you need sophisticated knowledge, the only way to do it is doing science. So science and education will be even more important than they are today, because that's the only way to solve the problems that we have to solve. So the role of the human scientist will be to guide research into this global challenge, to address these global challenges and trying to solve them and to improve our lives even better than we're improving. To try, for instance, decrease inequality and eliminate poverty and so on and so forth. These are big problems. And we need to use knowledge, we need to use science to solve them. So, so there is a lot for us to do, especially in working with AI systems, which will be much better than we are in terms of the perform intellectual tasks, but to improve our societies.
Thank you again, Professor Oliveira, for your exciting and informative talk today, and also for patiently answering all those queries from our audience.